Welcome. In the last video, we look at order of magnitude and how to calculate order of magnitude. In this video, we want to look at building models. We want to look at what we mean by models, what we mean by theory, what we mean by laws. Now, how did we come to know the laws governing natural phenomena? We have a lot of laws governing natural phenomena. One of them is Newton law of universal gravitation. Um, Newton laws of motion and the likes. How did we come about all these laws? First of all, we need to know what we mean by laws of nature. When we are talking of laws of nature, what do we mean by laws of nature? Laws of nature are concise descriptions of the universe around us. One thing about scientific laws is that they are descriptive. That is, they describe nature. They describe the universe around us. Unlike when I say descriptive, I mean I'm talking about natural sciences. The laws of natural sciences, they are descriptive. Unlike laws in social sciences like economics, they are usually prescriptive to prescribe something. But natural laws are there already. They are not actually made by men. They are there in nature already. Our main goal is just to discover them. For example, how the Earth and the other planets revolve around the sun has been there even before we discovered that. But the thing is, our goal is just to find that um, out, which we have been able to do. Now, when we are talking of laws of nature are concise description of the universe around us. So, as I've said, laws of nature, that's natural laws, they are descriptive, they are not prescriptive. So, they describe things around us, how they work, the outworking of things around us. Now, they are human statements of the underlying laws or rules that all natural processes follow. They are intrinsic to the universe. Now, of course, they are human statements, but they are there already. It is when we discover them that we come up with a particular statement that describe those actions in nature. The cornerstone of discovering natural laws is observation. Scientists must describe the universe as it is, not as we imagine it to be. It is very, very important as scientists to describe nature, the universe as it is. We cannot bring our own mind when we are talking of laws of nature. Ours is just to find out what that law is, what the law that is governing nature is, not for us to prescribe it. It is not like laws in economics or any other social science that we have a say. We have to just prescribe a particular law or something. Now, when we are now talking of model, what is a model? A model is more or less a mental picture. Model is not a real theory, it's not a real law per se, it's not a law per se. It's just okay. For example, look at Bohr model of single electron atoms. It's not as if anybody has seen an electron before, but that model is actually using the idea of the revolution of the electron around the nucleus of an atom. It is using it is using it also to it makes it looks like um the planet around the sun. What I mean is that the nucleus of an atom, the electrons in that nucleus is moving around the sun. So it is an analogy, yes, that is using the how the nucleus, the electron is moving around the nucleus, using it as an analogy of how the planets are revolving around the sun. So it is not a real law, but from there we can actually get some facts From there, the idea of spectral lines and the likes were gotten as a result of this Bohr model of single electron. So a model is a representation of something that is often too difficult or too impossible to display directly. It is accurate in describing certain aspects of a physical system. So example is Bohr model of single electron. So that Bohr model of single electron, actually what it actually say is that the electron move around the nucleus in like manner as the planets rotating around the sun, revolving around the sun. So from there, we're able to be some things are gotten and some things are predicted. So the idea of model is just to help us with something that we cannot see and be able to predict and to get some results from those things. Now, theory. When we are talking of theory, this is a testable explanation of patterns in nature supported by scientific evidence and verified multiple times by various groups of researchers. When a scientific discovery has gotten to the realm of theory, it is from theory that it becomes a law. So when it gets to the realm of theory, it has been tested a lot of times. Of course, not generally true in all cases, but most of the time it is actually true. That is when it becomes a theory. Now, the study of science in general and physics in particular is an adventure, much like the exploration of an uncharted ocean. When we are talking of the study of science, there are a lot of things here to be discovered. As Richard Feynman once said, that there are some things have to be learned to be unlearned, and unlearned to be learned. So there are a lot of things yet to be discovered. Discoveries are made, models, theories, and laws are formulated, and the beauty of the physical universe is made more sublime for the insights gained. So, as a scientist, models are important, theories are important, laws are important.